In today's lesson, we will be looking at graphs of the exponential function. So this should be mostly review. You've done the exponential function before in Algebra 2. And then we have been transforming functions all year, shifting them left, down, up, right, expanding them, reflecting them, and all of that. So a lot of this should be review, but looking at, so here is the exponential function a times b to the power of x. So x is the exponent. So exponential growth is when you have b is greater than 1. It creates this graph right here, where as x approaches infinity, y approaches infinity. But as x approaches negative infinity, y approaches 0. So we have to deal with asymptotes. Okay, and in just the basic parent function here, we have the y-intercept is 1, and that is when that a value is 1, and we just have b to the x. And then exponential decay is when b is between 0 and 1, and that is going to create this graph, which essentially what it changes is the end behavior. As x approaches infinity, y approaches 0, but as x approaches negative infinity, y approaches infinity. Okay, so this also would have the y-intercept of 0, 1, and that is when we're looking at that y equals b to the x, where a is just 1. Okay, so some other key facts. So exponential function, the domain is always going to be all real numbers, which we could also write negative infinity to infinity. But the range for these ones, it's always based on that asymptote. So it would be all y values greater than, but not including 0. And we're going to be shifting that asymptote up and down, so that's going to change our range. So we could also write this as 0 from 0 to infinity. And then x and y intercepts. So here's the y-intercept on both of these. Exponential functions will always have a y-intercept. They sometimes, and sometimes do not, have x-intercepts. So in this case, there is no x-intercept because of the asymptote. And then the asymptote, remember to write the asymptote. It is the horizontal line at y equals 0. And next we are going to look at transforming the exponential function. So y equals a times b to the power of x minus h plus k. So what happens when we add numbers at the end, add numbers in the x, maybe change these to negatives, and looking at all those transformations. Okay, so for this page of your notes, we are going to be transforming this y equals 2 to the power of x. So I know I didn't give you that graph, but you could pause the video right now and just do a very quick sketch. It doesn't have to be perfect. We're just going to get kind of main idea of what will happen on these graphs. So each of these graphs is this base function y equals 2 to the power of x. So what happens if we have y equals 2 to the power of x plus 1? What that does is it shifts all of the x values left 1. So if we just took some of these points, shifted them left 1, we're going to have a graph like this. It has the same asymptote. It's just shifted over. Okay, let's look at the next one. Y equals negative 3 times 2 to the power of x. So I've multiplied a number in front and I have made it negative. So it's going to do two things. The negative is going to cause a reflection across the x-axis. And then that -3 is going to kind of expand it vertically by a factor of 3. So I'm just going to do a rough sketch, not looking for perfection right now, but there's my reflection, and then it actually would go down here to be down at -3. All right, so now y equals 2 to the power of -x. So when you put a negative in front of x, it's a reflection over the y-axis. So this point will stay here, this point will reflect over here. Let's see, this one will go over here. Okay, so just a sketch to show this reflection. Okay, 3 down, 3 to go. Next one, y equals 2 to the x, and then at the end is this plus 3. So that is going to shift this asymptote that's at 0 up to 3. So just shift all of your points up 3. Okay, so the next one, very similar. Y equals 2 to the power of x minus 3. So you can guess that is going to shift down 3. So kind of lost that part of my graph, but we'll just put it down here. So the asymptote will be down here. So notice on this one, this is the first one where we actually have an x-intercept. None of the others do we have an x-intercept because of where the asymptote was. Okay, and the last graph, y equals 1/2 times 2 to the power of x minus 2 minus 2. All right, lots going on here. The first thing I always do is, if there's a number at the end, I'm going to graph my asymptote. It's going to go down 2. Okay, and then this right here is going to be right 2, and this 1/2 is going to be a compression. So just doing a rough sketch, it'll look like this. So for our notes, we're just doing kind of rough sketches just to kind of get the idea of these transformations. On our assignment, we're going to be more exact by getting those exact values. But there's your full video, so good luck with the lesson.